Welcome to Tomorrow Unveiled. We are diving into what feels like a real watershed moment in artificial intelligence this week. A time where the field seems to have definitively shifted gears.
Yeah, it feels like more than just the usual incremental updates we see.
Exactly. For years, AI systems have mostly been, well, reactive tools, haven't they? Waiting for you to give them a prompt, a command, ask a question.
Brilliant answer boxes, but fundamentally passive.
Right. The source material our dedicated research team pulled together this week, covering September 22nd to the 29th, it confirms we're crossing a threshold, a big one. It looks like the era of the proactive, autonomous AI agent is really starting to arrive.
And that's key proactive. Systems that can reason, plan, and actually execute complex actions for you, sometimes without you even asking directly.
With judgment.
With judgment, yeah. And
Yeah.
this shift, it's huge. It's not just a software thing. It's like a convergence.
The convergence. How so?
Well, breakthroughs across the whole tech stack, all landing around the same time. You've got new hardware architectures solving fundamental problems like heat dissipation.
We'll definitely get into that.
Yeah. And then algorithmic discoveries that actually automate invention itself, plus, better safety, better governance to manage all this new autonomy.
Right. It's like all the pieces had to evolve together.
Exactly. You can't have truly autonomous intelligence without the foundations keeping pace.
Okay. So our mission today on Tomorrow Unveiled is to synthesize all these findings, corroborated by our research team. We've broken it down into 4 key pillars, supporting what the industry is calling the agentic paradigm.
The agentic paradigm. It's a good term for it.
I think so too. And this deep dive, it might fundamentally change how you think about working with AI, moving from just giving commands to setting, strategic goals for these sophisticated digital partners. So let's kick things off by defining this destination. We're using the term AI agents, but what really makes an agent different from, say, a clever macro or the chatbots we've used for the last couple of years?
Okay, yeah, good question. The core difference really boils down to 3 integrated things: reasoning, planning, and executing complex end-to-end workflows autonomously.
End to end.
Yeah. Think about a typical chatbot. You ask, it answers, want more. You prompt, again, often with lots of detail. It doesn't really remember the context beyond the immediate turn.
Right, it's stateless.
Exactly. An agent is different. You give it a high-level goal. Something like proactively resolve all customer shipping delay issues this quarter.
Whoa, okay. That's not a simple command. That's a whole project.
It is, and the agent can break that down. Okay, first, monitor the supply chain data in real time. Second, figure out which customers might be affected. Third, draft personalized messages. Maybe email, maybe SMS.
Okay.
Fourth, grab a compensation voucher from the CRM system. Fifth, check back later, did the customer respond? Are they satisfied? It's juggling tasks across different system logistics, email, databases.
Then handling errors.
And handling errors, monitoring its own progress, all without someone needing to hold its hand at every step. It's not just doing one task, it's orchestrating a whole dynamic process.
And our research team found this isn't just theory anymore. It's actually creating a new blueprint for businesses, this idea of the agentic organization.
That's what the industry analysis is confirming,
Yeah.
It's a complete overhaul, really.
How does it change the human role?
It fundamentally flips the script. In old automation, humans were often in the loop, right? Clicking approve, verifying data points. In the agentic organization model, humans move on the loop, or more often, above the loop.
Above the loop. What does that look like in practice?
Your job becomes strategic oversight. Setting the big goals, the why. Handling the truly weird stuff, the exceptions the AI hasn't seen before. The agent handles the how.
So humans focus on strategy and novelty.
Exactly. And this allows for things like hyper-personalization at scale. And critically, something the source material really emphasized, it pushes towards near zero marginal costs for a lot of digital processes.
Okay, wait. Near zero marginal costs. That's huge economically. We should unpack that a bit. What kind of processes could become essentially free to scale?
Well, think about dynamic pricing adjustments or complex fraud detection or maybe predicting customer churn and sending out personalized retention offers.
Okay.
Previously, doing more of that meant hiring more people, scaling up infrastructure. There was a real cost for each extra customer or transaction you handled.
Right, a marginal cost.
Yeah, but when an autonomous agent handles the reasoning, the execution, the response, like the example our team found of Amazon proactively sorting out a delivery issue before the customer even complains.
Right.
The cost of doing that for one more customer once the system is built, it gets very, very close to zero.
That completely changes the economics.
Well, it does. It forces companies to rethink where human talent provides the most value, which is increasingly in the strategic, creative, non-routine work.
And we're seeing real examples already. Amazon's proactive service is one. The research also mentioned logistics, right?
Yes, absolutely. Our team highlighted companies like DHL using agents for supply chain optimization, dynamic rerouting.
So if there's bad weather, delaying a ship.
Or, say, a sudden customs issue for a critical part in one specific port. The agent doesn't just raise an alert. It thinks through alternatives, checks data across maybe hundreds of carriers, plans a new route, sorts out the paperwork.
All automatically.
All within seconds. Compare that to a human team trying to coordinate calls and emails. It's the difference between a minor hiccup and a major supply chain disruption.
That speed is incredible. Now, moving down from the big enterprise stuff to us, the consumers, there was a key launch this week, a sort of stepping stone towards this agentic future. ChatGPT Pulse.
Ah, yes. Pulse. It's interesting because it's such a deliberate move away from the chatbot model we all know.
For pro subscribers.
Yeah. And the idea is it works overnight. It synthesizes information not just from the web, but from your private chat history, your connected apps, calendar, email.
So it's using my personal context while I'm asleep. What's the output?
You wake up, and instead of just a blank prompt, you get a personalized morning briefing. Proactive.
Trying to replace the doom scrolling.
That seems to be the explicit goal, yeah. Replace that endless scroll through generic feeds with something finite, curated, and actually useful for your day, based on your projects, your interests, stuff you've talked about before.
That anticipation acting before the prompt that feels very agentic.
Exactly. Even in just a summary format, it's embodying that core principle.
Okay, that makes sense for the digital realm. But this agentic trend isn't just software. It's hitting the physical world, too, through robotics. And some of these breakthroughs seem even more, well, disruptive.
Agreed. The physical side is moving fast. We saw Gemini Robotics 1.5 announced. And this isn't just about automating movement. It's about adding that autonomous planning layer to robots.
Right, because it combines a vision language model with something new. An embodied reasoning model.
Yeah.
Allows the robot to think transparently.
Precisely. So instead of just following pre-programmed paths, the robot can kind of narrate his own plan. You know, I see the cup there, I need to grip it like this for stability, and the best path to the table avoids that obstacle.
So you can understand its thought process.
Yeah, which lets a human supervisor check the reasoning, not just the final action. Huge for safety and debugging.
But the really big leap here, the one multiple sources flagged, is cross-embodiment learning. You said this solves a major long-standing problem in robotics.
It really does. It's tackled a huge bottleneck. Think about it. Historically, you'd spend ages training an industrial arm, say, to pick up a specific part.
Okay.
Then you get a new robot, maybe a wheeled delivery bot, completely different shape and mechanics. You basically had to start the training all over again. Different hardware meant different, expensive, time-consuming training.
It sounds like learning to ride a bike, then having to completely relearn balance just for a scooter.
Perfect analogy. Cross-embodiment learning breaks that. Gemini Robotics 1.5 allows skills learned on one robot type.
Like the physics of gripping something.
Exactly. Understanding physics, torque, navigation, learned on maybe a big assembly arm. That knowledge can be transferred and applied to a totally different robot, like a complex humanoid hand, without massive retraining.
It learns the abstract concept, not just the specific movements for one body.
That's the core idea. And the implication is, well, it could accelerate deploying intelligent physical agents in factories, hospitals, homes at a speed we couldn't imagine before.
That acceleration is the perfect bridge. Because you can't have this massive agentic shift without equally massive changes underneath. The infrastructure.
Absolutely.
You simply can't run millions of these reasoning, proactive agents on yesterday's hardware. They need a whole new compute stack.
Okay, let's talk heat. It sounds mundane, but for years, the physical limit on scaling AI has been the sheer heat coming off modern GPUs.
It's the fundamental bottleneck. The chips might be powerful, but if you can't cool them, you can't push them hard, and crucially, you can't pack them close together. No density.
And our research team flagged a major breakthrough here from Microsoft. A new kind of cooling.
A totally novel approach.
Yeah.
In-chip microfluidic cooling. This isn't just a bigger fan or a fancier external cold plate. It's changing how heat is managed right at the silicon level.
In-chip microfluidics? Sounds complex. How does it work?
It's actually bio-inspired, which you see a lot in cutting-edge engineering. They etch these incredibly tiny channels smaller than a human hair directly onto the silicon chip itself.
These channels mimic natural systems, like veins in a leaf or capillaries. Liquid coolant is then pumped right through these internal structures, flowing just milliseconds away from the hottest parts of the transistors.
So instead of cooling the outside packaging, you're cooling directly from the inside.
Exactly. Traditional cold plates have to pull heat through layers, the silicon, the solder, the heat spreader before reaching the liquid. Microfluidics bypasses all that insulation, direct contact.
And that makes a big difference.
A huge difference. The performance numbers are pretty stunning, and they were corroborated across the technical reports we saw. This system removes heat up to 3 times more effectively than the best current cold plates.
3 times. But what's the bottom line impact on temperature?
That's the most crucial figure. It can reduce the maximum GPU temperature rise by up to 65% under heavy load.
65% cooler under load.
Okay.
What does that unlock practically? How did that help the agentic paradigm?
Well, first, density. You can pack way more chips into the same space safely because the heat is managed right on the chip, needing less bulky external cooling.
Right, more compute per square foot.
Second, you can safely overclock the chips, run them faster when you need peak performance for these demanding agents. But the biggest thing, the real game changer, is that cooling between layers of silicon finally makes 3D stacked chip architectures practical.
Stacking chips vertically. That's been talked about for ages. But heat was always the killer.
Always the killer. If you stack processing layers, the heat just builds up exponentially in the middle. Solving that with microfluidics means you can dramatically shorten the distance data travels between layers, slashing latency, and cram much more processing power into a smaller physical footprint.
Which is exactly what these complex agents need.
Precisely the kind of power boost they'll demand.
And speaking of power and scale, the infrastructure news this week wasn't just about cooling. It was about massive investment. Exascale compute is the target, and the numbers are just mind-boggling.
The investment figures alone signal something big is happening. You hear about these huge data center deals that are reported, $100 billion OpenAI-NVIDIA partnership, or the whispers about a $500 billion Stargate project.
$500 billion.
Yeah. This isn't just adding more servers. This scale suggests the industry is building, like, dedicated AI nations of compute.
Okay, but how do you connect, say, thousands or tens of thousands of chips in an AI nation so they actually work together, not just individually? Avoid bottlenecks.
That's the interconnect problem. If agents are running models with trillions of parameters, the chips need to talk to each other almost instantly, like one giant brain. And Huawei announced a key piece of that puzzle, Unified Bus 2.0.
Unified Bus 2.0. What's special about it?
It's an open optical interconnect designed specifically for these massive AI clusters. They're superpods or superclusters. It allows thousands of chips to act as one logical computer.
One logical computer.
The innovation is in the open optical bus. It provides absolutely massive bandwidth, apparently up to 10 times the bandwidth of the entire global internet, connecting all these chips. Plus, it has near instant fault detection. This kind of plumbing is essential if you want to train and run those multi-trillion parameter models where everything needs to sync instantly.
It's the nervous system for the AI nation.
That's a good way to put it.
And where are the processors for these systems coming from? The research confirmed a shift in who's buying the most advanced chips, right? It's not just phones anymore.
Yeah, that shift is really telling. Look at TSMC's brand new 2-nanometer process, the N2 node. Super cutting edge. Our research indicates that 2/3 of the early customers lining up for N2 are high-performance compute and AI companies.
2/3, that's huge. Usually the newest tech goes straight into iPhones first.
Historically, yes. Mobile and consumer electronics always got the first bite. The fact that HPC and AI are now dominating the earliest, most advanced, and probably most expensive manufacturing capacity, it signals this intense industry-wide push for maximum compute power per watt. They need it for these agents.
Okay, this is a lot to take in: the cooling, the scale, the interconnects. If you're finding this insightful, just a quick reminder, please take a moment to like this video. If you're on YouTube, subscribe to Tomorrow Unveiled, and maybe hit that new hype button. It really helps us reach more viewers. And turn on notifications so you don't miss future updates.
Yeah, that support makes a big difference.
Okay, so we have the massive scale, the infrastructure. But it's not just brute force, right? There's intelligence being applied to the process of innovation itself. Which brings us neatly to Pillar 3, Meta AI. Right, Meta AI. The agentic paradigm and the infrastructure are two legs of the stool. The third seems to be AI systems that are starting to improve themselves, or even invent things. AI designing AI.
This is where things start to feel, well, like the speed is really ramping up, almost nonlinear. And the big news here this week was Sakana AI releasing their Shinka Evolve framework.
Shinka Evolve, what does it do?
Basically, it uses large language models to automatically discover and refine new algorithms, high-performance ones, for various kinds of tasks.
Okay, automatically discovering algorithms sounds incredibly compute-intensive, like you'd be testing endless variations, most of them useless.
You would, traditionally. But that's the clever part about Shinka Evolve. Our research team noted its unprecedented sample efficiency. It's not just brute-forcing variations.
How does it avoid that? What makes it efficient?
It uses a few smart techniques. One is adaptive parent sampling. It intelligently balances exploring totally new algorithmic ideas, taking risks, with exploiting things that are already known to work reasonably well, fine-tuning.
Okay, balancing exploration and exploitation.
Right. But the really novel part, I think, is what they call an LLM as Novelty Judge.
An LM is a judge.
Yeah.
So the AI itself decides if a new algorithm idea is interesting or promising.
That's basically it. The LLM looks at the generated code or the description of a new algorithmic approach and uses its understanding of language, code, and maybe past experiments to predict whether this path is likely to be fruitful before they run expensive full-scale tests or simulations.
So it filters out the likely dead ends early using reasoning, not just raw testing.
Exactly. It drastically cuts down on wasted computation. It's like having an experienced researcher guiding the process, saying, that idea looks promising, let's try it, or nah, that approach has failed before, let's skip it.
That's fascinating. So what kind of results does this intelligent evolution achieve? How much faster is it?
The performance examples are pretty impressive. The team highlighted one, the classic 26-circle packing problem. It's a really tough geometric optimization challenge.
Okay.
Shinka Evolve apparently found a state-of-the-art solution using only about 150 samples, 150 trials, compared to older methods, human or traditional AI, that needed maybe thousands of samples. It's a huge leap in efficiency.
Wow. That kind of speed up really makes the idea of an AI co-pilot for scientists and engineers feel much more real. It's accelerating the research process itself.
And we're already seeing this AI-driven science delivering concrete results, real breakthroughs corroborated by the research, moving beyond theory into actual hard science.
Yeah, the research highlighted AI tackling bottlenecks in physical sciences, like finding new materials.
Right. A great example is the BENet model. It's a specific type of neural network, an equivariant graph neural network that's tailored for processing geometric data, specifically crystal structures.
Equivariant. That sounds technical. Why is that specific property good for crystals?
Okay, so equivariance basically means if you rotate or shift the input, like look at a crystal lattice from a different angle, the way the network represents that structure internally changes in a corresponding, predictable way.
So it understands 3D geometry inherently.
Exactly. A normal network might need to see hundreds of rotated versions of the same crystal to really learn what it is. An equivariant network gets the geometry more intuitively. This is crucial for crystals because their properties often depend heavily on their 3D structure and symmetry.
So it needs less data and generalizes better for geometric tasks like predicting material properties.
Precisely. And it's being used to tackle a huge challenge, finding new superconductors.
And how's it doing?
The results are striking. Our research team confirmed that BNet has already led to predicting, then experimentally making and verifying 2 completely novel superconductors.
Wow. And the time frame.
The whole AI-driven workflow, prediction, synthesis, verification took about 3 months, a process that used to take years of lab work and trial and error.
Years down to months. That completely changes the economics of materials discovery.
Absolutely. And beyond superconductors, there was also MIT's SCIGen tool. This one embeds known physics and chemistry design rules into the generative AI process.
So it doesn't just dream up impossible materials.
Right. It keeps the AI's creativity grounded in physical reality while still exploring novel structures. They're using it to design exotic quantum materials, which could be huge for semiconductors, batteries, you name it.
Okay, this connects back to what you said earlier about the virtuous cycle.
Yeah.
The link between the infrastructure, Section 2, and this meta AI, Section 3, how do they feed each other?
It's a perfect feedback loop. The hardware breakthroughs like the microfluidic cooling we talked about enable denser, faster compute clusters.
Right.
That massive compute power is exactly what lets these meta AI systems like Shinka Evolve, run faster, explore more complex algorithmic spaces.
Okay.
And what do these meta AIs do with that power? They discover more efficient, more powerful algorithms like BNet for material science, which can then run even better on the new hardware, or maybe even help design the next generation of hardware.
So better hardware enables smarter AI discovery, which creates better algorithms to use the hardware, which drives demand for even better hardware.
Exactly. It's a self-accelerating loop, and that's what's driving the incredible pace we're seeing towards this agentic paradigm.
So the meta AI isn't just making things bigger, it's making them smarter, more efficient. Which leads us to the next big trend our research team confirmed this week. A noticeable shift away from just chasing massive general-purpose models.
Yeah, there's a growing focus on lean, efficient, often task-specific architectures. It's less about mine is bigger than yours and more about practical utility optimization.
Why the shift? What's driving it?
A lot of it comes down to practical needs, things like privacy, low latency, cost. If you want AI agents managing your personal finances or your calendar, like the agentic paradigm envisions.
You need them to run instantly and securely on your own device.
Exactly. You can't have everything going back and forth to the cloud constantly, especially with sensitive data. That's driving the push for on-device intelligence.
And a prime example landed this week. Google DeepMind released Embedding Gemma.
Yeah, Embedding Gemma is a perfect illustration. It's a text embedding model, but it's lightweight. Open source, too.
How lightweight are we talking?
Just 308 million parameters. Compare that to frontier models measured in trillions. When it's optimized, Embedding Gemma needs less than 200 megabytes of RAM.
So, small enough to run easily on a standard phone or laptop.
Comfortably. And its whole design philosophy is optimized for offline on-device use.
Why is that capability, running powerful embeddings locally, so important for privacy in this agentic world?
Because it enables really useful privacy-preserving applications. Think about retrieval augmented generation, or RAG, running locally across all your personal files, emails, notes, documents.
Okay.
You could ask an agent, hey, find my notes from that project meeting last month and summarize the action items, and all the processing happens right there on your device. No sensitive data leaves your control.
You get the smarts without the privacy trade-off.
That's the goal. Semantic search, understanding context across your personal information sphere, all done locally, quickly, securely.
And Embedding Gemma isn't alone, right? The research mentioned others pushing this on-device trend.
Right. Liquid AI's Liquid Nanos models were also noted, another family of very small, specialized models. Interestingly, they're non-transformer alternatives, but they're apparently matching the performance of much larger models on common device tasks. It reinforces this move towards efficient, specialized tools for the job.
Okay, so we have these efficient, specialized agents coming. They're going to be embedded in businesses doing real work. How do we know if they're actually any good at those real jobs?
That's a huge issue. The standard benchmarks, the academic ones, they often test things like answering trivia questions or performance on standardized tests.
Not exactly reflective of generating a quarterly report or summarizing customer feedback.
Exactly. They don't measure how well an AI performs complex, realistic corporate tasks, often involving multiple data sources or languages. And that's where Samsung's new benchmark, TrueBench, comes in.
TrueBench trustworthy real-world usage evaluation.
Yeah. Our research team flagged this as a significant step because it's designed specifically to fill that gap for enterprise adoption. It moves evaluation from abstract capability to practical, trustworthy utility.
What kind of tasks does TrueBench actually measure?
It focuses on things agents will actually do in a business context. We're talking complex summarization from multiple documents, data analysis that requires mathematical reasoning, generating presentations using extracted data, translation quality for business use cases.
Across different languages, too.
Yeah, it covers 10 task categories and 12 languages with nearly 2,500 test sets. It aims to give businesses a much clearer picture of whether an AI model can actually deliver value and be trusted for specific corporate workflows.
That seems crucial for companies trying to decide which AI tools to actually deploy. It shifts focus from just parameter counts to actual usefulness.
Definitely. It's about measuring productivity and trustworthiness in a real-world context.
Now, one final aspect of efficiency, and it's a big one looming over the entire field: energy consumption.
Yes. The elephant in the server room.
AI is incredibly powerful, but it uses a massive amount of energy. This paradox is forcing a shift towards energy-aware design, right?
It has to. The energy demands are becoming a serious constraint, both environmentally and economically. This is where programs like DARPA's ML2P come in.
ML2P mapping machine learning to physics.
Right. The goal here is pretty fundamental. It's about moving beyond optimizing AI models only for accuracy or speed. ML2P aims to map model performance directly to its physical electric characteristics, to measure energy consumption properly in joules.
Why is measuring performance in joules, the actual unit of energy, so important? We usually talk about computations per second, like FLOPS.
Because in many real-world scenarios, especially at the edge, think drones, sensors, and remote locations, tactical gear for soldiers' power is severely limited. Battery life is everything.
Right.
In those cases, a tiny increase in accuracy might not be worth doubling the energy drain. ML2P wants to give designers the tools to make those trade-offs explicitly. Maybe you sacrifice 0.5% accuracy, but you gain 50% longer operational time.
So it's about optimizing for energy efficiency as a primary goal, not just an afterthought. Essential for agents operating untethered in the real world.
Absolutely critical for edge AI and any power-constrained deployment. It ensures AI can be useful where every joule counts.
Okay, so we have these powerful, increasingly autonomous, specialized, energy-aware agents. The speed is incredible. But with all this power comes, well, responsibility. The governance aspect feels more urgent than ever.
It absolutely is, and the global community is definitely reacting. The discussions are happening at the highest levels, like the UN Security Council debate this week.
Yeah, the Secretary General's warning was pretty stark. Humanity's fate cannot be left to algorithm. What were the specific concerns being raised there, based on the research?
It wasn't just abstract fear. They focused on concrete risks emerging right now. First, the power of these systems to generate convincing fake media, potentially amplifying polarization or manipulating public opinion at scale.
Deepfakes and disinformation on steroids.
Pretty much. Second, the geopolitical angle. The sheer energy and water resources needed to train and run these massive AI systems could become a source of international tension or conflict. Competition for resources. And third, just the basic issue of accountability. When autonomous agents are making complex decisions that cross borders rapidly, who is ultimately responsible when things go wrong? The consensus was clear. Policy needs to accelerate to keep pace with the tech.
And the industry itself is trying to build guardrails. We saw DeepMind update their frontier safety framework to version 3.
Yes, and V3 seems like a direct response to this rise of agentic AI. It introduces new critical capability levels, specifically targeting risks around harmful manipulation.
Harmful manipulation, like what?
Like scenarios where sophisticated AI could systematically influence or change human beliefs and behaviors on a large scale. The framework also mandates stricter safety reviews before deploying advanced internal systems, particularly looking at risks like an agent-resisting shutdown if its goals diverge from human intent.
Wow, they're really thinking about sci-fi scenarios becoming potential engineering problems.
They have to. When systems act proactively and autonomously, these kinds of alignment and control issues become very real safety concerns.
Okay, beyond the big policy questions, there are also specific technical threats. Our research team highlighted a new privacy attack called CAMIA.
Ah, yes, the context-aware membership inference attack. This one's subtle, but quite concerning.
What does it do? How is it different from older privacy attacks?
So older attacks often tried to guess if a specific data point, like someone's specific sentence, was used in the training data. CAMIA is more sophisticated. It detects if a generative model has memorized specific training examples by looking at how the model behaves while it's generating text.
How does it do that? What's the signal?
It monitors tiny fluctuations in the model's predictive uncertainty at the level of individual words or tokens. Apparently, when the AI generates text related to something it memorized from its training data, its internal confidence score, how sure it is about the next word, changes in a characteristic pattern.
So the AI's own internal humming and hawing about its confidence level actually leaks information about the private data it was trained on.
That's the implication, yes. The contextual uncertainty curves carry these faint fingerprints of memorized sensitive information, even in supposedly black box models.
That really underlines how hard it is to truly anonymize these massive data sets.
It does, and it highlights the ongoing need for strong privacy-preserving techniques like differential privacy, especially as these agents start handling more and more personal data proactively.
Okay, one last piece, and it's a really grounding one. A reality check on all this speed and autonomy coming from a U.S. Air Force experiment called D-Day-HH.
Right, the DSH experiment. This is about using AI for military battle planning, and the speed results were, well, incredible.
How fast are we talking?
The AI could generate potential battle plan options 400 times faster than experienced human staff. Tasks that took weeks were done in hours.
400 times faster. That sounds amazing. But there's always a but.
There's the catch. While the speed was undeniable, a significant chunk of those AI-generated plans were just wrong.
Wrong how?
Non-viable. Logistically impossible. Ignored critical real-world constraints. Basically, the AI was super fast at generating ideas, but many of those ideas wouldn't actually work in reality.
So speed isn't the same as utility or viability?
Not at all. And this experiment perfectly highlights the core challenge for any agentic organization, whether it's military, business, or science. How do you leverage the incredible speed and scale of AI?
Without it generating disastrous plans because it missed some crucial context.
Exactly. It shows that human expertise, judgment, and that deep understanding of real-world constraints are still absolutely essential for validation. The human role shifts from doing the initial drafting to being the crucial quality control, the ultimate viability check.
You need the human above the loop to make sure the super-fast agent isn't driving off a cliff.
That's a good way to put it. Harness the speed, but ensure robust human oversight for viability and safety. #tag outro. So if we pull back and look at the whole week, the picture that emerges is one of convergence and reinforcement.
Yeah, everything seems connected.
The hardware breakthroughs, like the cooling tech, they enable the massive infrastructure. That infrastructure powers the meta AI discovery engines like Shinka evolve.
Which then create more efficient, specialized models like Embedding Gemma or BNet.
Right. And all of this, the hardware, the meta discovery, the efficiency, it's all driving towards that strategic goal, the agentic paradigm. The big story is that shift from reactive tools waiting for orders to proactive systems that can reason, plan, and act.
It really feels like the central question is changing. It's less about if AI can do something, more about, okay, how do we actually build a resilient, efficient, and safe organization around these autonomous AI agents?
That's the strategic challenge now.
And a research team's analysis suggests we're going to see these agents become mainstream pretty quickly. Across industries, likely in the 2026-2027 timeframe, it's set to fundamentally change how humans and AI work together.
And think about this acceleration loop. We're rapidly heading towards a future where the core algorithms running our complex systems, discovering drugs, managing global logistics, maybe even financial markets, those algorithms might well have been invented or at least significantly refined by an AI itself. As these systems become more capable of self-improvement, you have to wonder who or what is ultimately the master engineer in this emerging reality.
That is definitely a provocative thought to end on. Who is the master engineer? Well, that's all the time we have for today. If you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could take a moment to leave us a rating and review for Tomorrow Unveiled. It genuinely helps new listeners discover this show.
And we really do love hearing your thoughts. Whether you're watching on YouTube or listening on your favorite podcast app, please drop a comment. Let us know what you think about this big shift to proactive AI agents. How do you see it impacting your world?
Thank you for joining us for this deep dive on Tomorrow Unveiled. We'll see you next week.